Hello everyone, this is the Problem of the Week solution video for March 5th Problem of the Week, Railroad 2. I'll read through the problem description and then go through an example solution in Python. The problem description goes as follows. Theta likes to play with her Duplo railway set. The railway set she has consists of pieces of straight tracks, curved tracks, Y-shaped switches, and X-shaped level junctions, as well as bridges that allow one track to cross over another. There are also straight tracks that are railroad crossings that allow car traffic to cross. Close-ups of some of the pieces are shown below. Here's the 3 pictures of the track. And to play, she picks a number of X-shaped level junctions and a number of Y-shaped switches and connects them with straight and curved pieces using bridges as necessary. Because the set doesn't include any bumpers, she wants to build a closed track, like all the examples shown in the manual that came with the set. And this is figure 1, various track layouts possible with the Duplo railway system. Curved pieces are shown in green, straights in red, switches in orange, level junctions in yellow, bridges in blue, and crossings in black. Duplo is a trademark of the LEGO group. Unfortunately, sometimes this doesn't seem to work with the number of X-shaped level junctions and Y-shaped switches she starts out with. She quickly figures out exactly when it is possible to build a closed track. Can you figure it out too? Spoiler alert, we do figure this out. Write a program that outputs if it is possible to build a railroad that does not require any bumpers, i.e. which does not have any dead-end tracks. As for our input will consist of a single test case with 2 integer numbers, x, where 0 is less than x is less than 1000, and y, where 0 is less than or equal to y is less than or equal to 1000, denoting the number of level junctions and switches, respectively. You may assume that theta has sufficiently many straight and curved pieces as well as bridges. As for our output, we're supposed to output possible if she can build a closed track using all level junctions and all switches without any dead ends, or impossible otherwise. And here are some of our sample cases. Okay, so it seems that we have a certain pattern going on here. There must be an even number of track segments in a certain loop to close the loop using the connectors that are made available to us, as you can see in this picture. So all we have to do then is to calculate the number of track segments that there are. Luckily, this is as simple as multiplying the number of tracks that each connector can accommodate by the number of connectors there are, which is 4 for the X pieces and 3 for the Y-shaped pieces. Let's go to the example code and see how this all comes together. Alright, the first thing we do here is we use the input and slip functions to take in the 2 numbers of connectors and put them into 2 variables which I named x and y for their shape. Then we need to figure out the number of track segments in this railroad. This calculation all happens in line 5, where we multiply the integer value of x by 4 and add that to the integer value of y multiplied by 3. This operation coincides with the pattern that we identified earlier on. Note that there are integer casts on the x and y variables as Python takes in strings during the input. So the last section of code we have here is to see if the number of track segments are odd or even. If it's even, then the track layout is possible, and we print these conditions out in lines 8 and 9. And that is all we need to do in the code for this problem. So let's try out the example scenarios. Our first test case is 1 and 0. That should be possible. Our second test case is 0 and 2. This should also be possible, and it is. And our last test case is 1 and 3. This scenario should be impossible. There we go. Alright, our program is working as we intended it to. That'll be it for this video. Thank you.